Hello, I'm Dr. Levon Hairapetyan, a business professor at Houston Baptist University. In this short video tutorial, I will demonstrate how we can use k-nearest neighbors algorithm for prediction, or in other words, for estimation of a value of a continuous variable. We already did a similar thing, but we used k-nearest neighbors for prediction, for classification. Now we'll learn how we can use the same method for estimation of a continuous variable. I will demonstrate that on the example file called credit scores, and we will use this method to predict the credit score for new customers. And those new customers, I already have Excel file when I have new customers, which contain the same information. About each customer, we have the same information as in my original data, except we don't know the credit score. And that's the goal, to use k-nearest neighbors method to predict or estimate the credit scores for these new customers. Let me switch to Excel. So this is the file. And here there is a tab which describes the fields like credit score. This is the scores, and then next bureau inquiries, that number of inquiries about an individual, and so on. So these are all explanation of these variables. And we have, let's see how many, we have 4,898 observations, so almost 5,000 observations, which means almost 5,000 information about 5,000 the credit card holders. What we want to do, and is one of the fields, which is the credit score. This is what will be the crucial for us. That's what will be our continuous variable, and which we'll use to predict or estimate the value of continuous variable. I have another file. Let me show that also. This is the file, not this one, this one. So I created a new Excel file, and I just generated a new Excel file with new data. These are data about the customers. These are just made up names. Obviously, I made them up. And so I have several new customers, and for each customer, I have the same information which was in the original data, except I do not have a credit score. So the goal will be in this next few minutes to use k-nearest neighbors method to estimate scores of these new customers. Now let me go back to original data. Now I'm about to implement this k-nearest neighbors method. However, I want to remind you that before using any of these methods, whether classification method or estimation method, we need to divide our data set into those three sets: training, validation, and testing. So it's called partitioning. First, we have to do partitioning. In my previous example, when I did k-nearest neighbors for classification in another video, data was already partitioned. So here I intentionally didn't partition before. We will do it together. Since this is just the credit score is not a rare event, so there is no need to use partitioning with oversampling. It will be just standard partitioning. So I will go and do a standard partitioning. Click anywhere inside of the data, go to the data mining, then partition in data mining group, and we will select standard partitioning. We will select all variables for partitioning. I'll keep this all. Let me change. I will specify the percentages. This is commonly used percentage: 50% for training set, 30% for validation, and 20% for test set. And that's it. I'll just click OK, and partition will be done just in a second. And here is the partition data. Now my data set is partitioned, and I will use this partition data set to do k nearest neighbors method. Pay attention, if you try to be here and implement that method, it will not work because this data is not partitioned yet. That's why we partitioned first. Now I will click anywhere inside of this partition data. And now I will go to data mining. And what we want to do, we want to predict by using k nearest neighbors. I will use the record ID, obviously is not a real variables label. So I will select all these variables which will be used for prediction. Click, they will become my selected variable. And the variable which I'm about to predict and the variable which I want to be able to estimate its value is credit score. So I will click this, and this is my output variable. Click next. Here we have to specify which k nearest neighbors method do I want to use, which means I have to specify the value of k. Since I don't know which value of k is the best, is it 1, 2, 3, 4, or 5, or whatever? So I will ask Analytic solver to calculate, to do for various k's, values of k, and then select the best one. That's why I click here. Search from 1 to k, and I will specify the value of k, let's say 10. By selecting this option, I am asking Analytic solver to try the first 1 nearest neighbor, 2 nearest neighbors, 3 nearest neighbors, up to 10 nearest neighbors, all those 10 methods, and then whichever is the best, select that one. And the best will be the one which generates the smallest error. Then click next. And here you have to specify what do you want to see. This time I'll just select summary reports. But this is the important part. Remember, we want to be able to predict the credit scores for those new customers. And therefore we have to provide the information about those new customers. And that information was in a separate Excel file. Let me make it, just make sure that we are clear on this. Last time when we used new data, we brought new data into our original Excel file and then as a separate worksheet and used it. But now I'm doing different way, which is more flexible way. Instead of bringing and attaching and using it, we just select the file which contains data about new customers. So I will click here. And now, last time I went here and selected worksheet. Now I need to select workbook. Workbook means Excel file. Click here, and this is the Excel file, new data for estimation. That's the file which I created, prepared. And when I select it, you can see that this file now is opened and active. And here, the variables of this new file are listed here. And these are the variables in my original file. Now I have to tell how these variables are related to each other. Since this common technique, when you use all the same variables, then you just click match by name, and variables will be nicely matched by name. And we're done. We'll just click finish and wait a little bit. And you can see that we got several new worksheets. Let's start with this K. This K nearest, KNP stands for K nearest neighbors for prediction. And this is the name of the tab output. So if you scroll down, here you will see this is the information which I want to show you. Remember, we asked Analytic solver to do for various values of K from 1 to 10. So it did. And so then for each K, it calculated RMSE. This stands for root mean square error. We discussed this in one of our previous videos. And whichever is the smallest error, that's the best key. K, the best value for K. And as you can see, the smallest error is when K is 9. Therefore, after this step, when Analytic solver figured out what is the best value of K between 1 and 10, then for the rest of the calculations, this very value will be used. Then we have several information about the training set, validation, test set. I have explanation of many data on the slide. But what I want to emphasize here is new score. Remember, our goal was to predict credit scores of new customers, and that's what software did. And this is the credit scores which software predicted for those 22 customers. Let me copy this and put next to those names of those customers so we can make better sense. Copy. And let me move to, so this was the new set. This was the new set which we were planning to predict credit scores for these people, and solver did it. So these are the credit score for Sherry Melton. The credit score is 650, and so for anybody you can say, like Jeremy, credit score is 639.59, and so on. To summarize what we learned in this short video, we learned how we can use Analytic solver to do k-nearest methods, to implement k-nearest methods algorithm in order to estimate or predict the value of a continuous variable. In this case, that continuous variable was credit score, and we learned how we can do that. This concludes my short lecture. Have a nice day. Bye.